Hello everyone, I'm Haura and today I'm gonna talk about the Van Allen radiation belts. I'll start my presentation with a short video, hope you like it.
Space weather can be as unpredictable as the weather on Earth. Periodic eruptions on the Sun's surface eject huge clouds of highly charged protons and electrons. Some of them reach the Earth and collide with nitrogen and oxygen molecules and cause spectacular light displays like the aurora borealis or the northern lights. And when the clouds of charged particles are usually strong, they can knock out power grids and even damage electronic equipment. But most of the time they get trapped by the Earth's magnetic field in the so-called the Van Allen radiation belt. But what is that exactly? Let's get into the PowerPoint to explain more.
I will not start directly with the definition of Van Allen radiation belts, but I want to explain something that will help you understand what I'll be saying throughout my presentation. So fortunately, our planet has a protection. It is surrounded by a magnetic field which is generated by the liquid iron core at the center of the planet. And this flow of liquid iron generates electric current. So as you can see here, this is our liquid iron core that generates electric current, and this in turn produces magnetic field. And we already know that whenever an electric current is flowing, there will be a magnetic field. But you will now tell me, how is that even related to what you're saying and to your topic? And many questions popped into your mind while I'm explaining this. So the magnetic field, which is also known as the geomagnetic field, is really important. But why? I'll explain it in the next slide. So we need this field because our sun produces violent solar storms, which are the charged particles fired from the sun. So in fact, our planet is constantly bombarded by a steady stream of high energy particles from the sun. And in addition to this, we have cosmic rays, which are high energy particles that are mainly originating from the outside of the solar system and striking into our planet. And without the Earth's magnetic field, these cosmic rays and high energy particles would strip away our atmosphere. So without it, the solar wind would blow our atmosphere away, and without the atmosphere, liquid water couldn't exist on the surface, and the oceans would boil away, leaving the dry, sterile red rock that we see today on Mars and many other planets. So luckily for us, we have our magnetic field, the magnetosphere, to protect us from most of the harmful particles. And you may say now, Haura, how can a magnetic field protect us from these particles? And here comes the Van Allen radiation belt role. So, of course, when the charged particles come into contact with the magnetosphere, they don't just disappear like that, but they are deflected around the planet, forming these belts. And they were discovered in 1958 by a group of United States scientists under the direction of Dr. James Van Allen. And the discovery was based on information obtained from Explorer 1, which is American's first artificial satellite. So as you can see here, this is the solar energetic particles coming from the sun and the cosmic rays, and here is the Earth's magnetic field, and they are going towards it. Yes, and this is James Van Allen, and here is Explorer 1, and this is the Van Allen probes that I'm gonna talk about them in a second. So at the time of the discovery of Van Allen belts, not many details were known about them, and they were the subject of great interest. But today, an accurate understanding of them is crucial, as they are a threat to the man-made satellite that our society heavily relies on. And the high energy particles that form this belt can damage electronics such as the solar cells and sensors. So, in fact, orbiting technology like the Hubble Space Telescope regularly gets turned off as it passes through areas of high intensity. And in order to better understand these belts, in August of 2012, which was the 60th anniversary of Explorer 1, NASA launched the Van Allen probes, and these probes constantly collect data, gathering valuable information as they spin and orbit our planet. So basically, the Earth has two belts. One is Van Allen, and the second appears to be temporary. But our focus will be on Van Allen belt today. So this belt is divided into two other belts, the outer and the inner belts, and they are centered along the Earth's magnetic equator in a region of the upper atmosphere, which is called the magnetosphere, as I said before, or you can say the exosphere. And they are known as radiation belts because they do not shape regions within which they are confined encircle the Earth like a huge belts. The charged particles that form these belts are mainly protons and electrons, and these particles move constantly, and at times they hit each other and lose their kinetic energy within a consequent emission of radiation. The particles can reach high energies over 30 kilo electron volt. The inner belt is situated at a distance between 700 and 10,000 kilometers, and it consists essentially of high energy electrons and protons. And the outer belt is at a distance between 13,000 and 65,000 kilometers, and it consists of even higher energy electrons than those of the inner belt. And the presence of these belts is dangerous mainly for astronauts orbiting the Earth at a height of 400 kilometers. They are subjected to a dose of radiations that is hundreds of times greater than the amount typically observed on Earth. And this involves a high risk of tumors and the damage to the nervous system and genetic modifications. And understanding the belts is important for spaceflight, and most satellites generally stay below the belts, but any craft that spends much time in the belts can receive a hefty jolt of radiation, which is enough to fry unprotected systems. So spacecraft operators need to know what to expect from the belt so they can shield their hardware from one of the many hazards of a spaceflight. And the most particular reason to study the radiation belt is that understanding them can help protect people and spacecraft from geomagnetic storms. And studying the radiation belts will also allow scientists to predict how solar storms will affect the planet and will allow advanced warning in case electronics need to be shut down to protect them from radiation. And this will also help engineers to design satellites and other spacecrafts with the right amount of radiation shielding for their location. So yes, that's all for today. And thank God that we have this magnetic field that protects us from all of these harmful radiations and highly energetic particles. So yes, this was the last slide. Thanks for watching and have a nice day.